Thank you. First of all, I would like to thank Productboard for having me. It's actually a pretty long time since I've stood before like real people, and yeah. So let me introduce myself. It's written here. I'm Tomáš Tunys. I'm one of the co-founders of Rossum, and the last 5 years I've led the research team. Um, I know it's not a good idea, but I know the abstract says something, and in the middle of doing the presentation, I have pivoted a little bit to something else. So sorry if it's not technical as you expect, but there is Slido, which is pretty good. So if you have any questions for the technical stuff, I don't cover, just ask. Okay, so this is the agenda. I will spend a few minutes just talking about Rossum, our mission, and how we are, what we are building, and how we want to reach this mission. Then the main part of my talk will be mostly about like the systems design, how you should think about the machine learning system, and like doing the research and how to improve. Actually, to the main point is main point of my talk is about building a self-improving system that you don't need uh, the real team in place every time to doing the stuff, running the models, training, and so on, and even annotations. It's maybe a good idea to outsource. So it's split into four sections. The first one is about data improvement. I'm talking about it in a sense of a feedback loop. So you want to create these feedback loops when it comes to the data acquisition, like selection of the data, and the quality and quantity data in machine learning matters a lot. So that's the first part. Then I will cover the dedicated engines. That's technical term we use for our custom machine learning models trained on our customers' data. Following with a few-shot learning loop, which refers to a problem we had with the dedicated engines and how we solved it. And the last part is about how the researchers' work actually leads to exponential improvement in the machine learning models and the performance of the Rossum as a whole. And the last part is wrap up. Okay, so how many of you actually heard about Rossum and knows what Rossum does? Oh, cool. Thank you. Okay, so our mission is actually to make B2B communication frictionless, which I don't know, it's explainable and clear on its own. But when you think about it, there are like millions of companies in the world, and they none of the companies actually lives on its own, and they need to collaborate, work together, and whenever they do, they exchange documents. Like think about the agreements, the invoices, other types of documents. And when you think about how many companies we have, how many documents you maybe in your work come into contact with, and your companies, then it leads to this like crazy amount that on every part, like every end of the connection, the communication channel, there are people that are actually working with these documents. They need to retype, let's say, the data from the documents into their ERP system and CRM system or other types of system, and that human touch point is actually making the friction, because they make delays, they make errors, and so on. And you know how it goes with, let's say, the due dates of invoices, how many of them are paid on time, and so on. So you can imagine the problem. Like every single company is kind of optimizes for their own sake, and not many companies are actually building products that like emphasizes this or tries to solve this problem of communication between the companies. So that's our place, and we want to make make it better. And one big thing is, and that's also about the individuality about the companies, is that they basically have their own formats. They can even use different languages, literally, like languages, and that make it hard because, one way to solve this problem is actually to build one standard or create a standard and say everyone will communicate in one standard. Just think about it like, I don't know, in your companies, in your teams, like when you need to collectively decide upon something, like how hard it is, and like thinking about on a larger scale that someone or some entity like, I don't know, European Union says that we will like exchange document in one format. Yeah, I mean, that will never happen. But that's what actually Rossum does. Um, we are building like this standard, and I will talk about how exactly I mean it. And this is in short basically what we are trying to solve. I mean, I don't know if you can read it from far behind, but it's about this gap in, it says someone copies and pastes data from a thing into another thing and to 15 minutes more if the person is on call, is busy. Let's say some process is automated or it's quick, then it's a huge delay because there is a person that needs to do something, and then again it's automated. So we want to make this gap as like small as possible, and how we want to accomplish that. That's the basically mission of our research team, and it says that we would like to teach computers to understand documents and basically help the people to actually do their job better, and even eventually they don't need to do that part of the job at all and can move to something more creative. Uh, like, I don't know how many of you have seen what we are actually building. This is the front end point of view. The goal of the research team is actually to extract every single field the customer wants and like needs. This is the header fields view, kind of, that's the invoice ID. And these are the line items. So we cover all sorts of fields. And our goal is really to automate this process as much as possible so that no user need to look at any document in the end. But even if we make mistakes, the people can make the changes, and I will talk about it later. But basically, from our customers, from research point of view, the customers are the annotators. So we made the users of Rossum and annotators. So anytime they fix something, annotate something, we just missed some prediction. They correct the prediction, and therefore we have the data to train the models on. So this is one of the important loops that we have created, and that makes the whole automation of the whole mission even possible. And the backend view, just to give you a glimpse into the technical part, and I could spend like hours talking about just like the following two slides. So there are basically two main components. That's the API, that's a service that receives the document and stores it and creates a job, puts it in a queue, and there are multiple workers that are basically loading the machine learning models, getting the job from the queue, and basically execute the extraction, the predictions, and the whole process. And after they're done, they save the predictions into some artifacts. So in our case, we run in AWS. All those services run in Kubernetes. Basically, almost all those except the artifact store, they are pods running in Kubernetes. And yeah, I mean, you could ask, like, we have multiple customers with different engines, but they share basically the queue. How do we like spawn different extraction engines? How do we like prioritize? How do we, I don't know, there are so many things. How do we scale the whole thing when the queue is like full of waiting jobs? How that thing work? And as I said, I will not go into it. There are so many things we can discuss just on the slides, but If you're interested, just ask. And one detail, that's the extraction engine. It's not like one single end-to-end neural network that's doing all the job, like detecting the fields on line items and doing the OCR. And it's actually a bunch of I don't know actually how many. Oh, sorry, what just happened? Okay, will not touch it. Okay, sorry about that. Back to it. Where was I? The number of models is just, I don't know, like maybe a top at 10. But the whole job of the extraction, what we are actually receiving is all the time is an image of the pages, and we do some preprocessing. There is so many things just the preprocessing does, like normalizing, desk queuing, that's like fixing the orientation but perspective. And then once we have this, like even downscaling the images, because the inputs cannot be just like the original format, and because maybe it would be too big for the extraction. So that's the preprocessing. Then all those fields listed, models listed here. There is this field detection network. That's job is to locate the fields on the document, give it the bounding box. Actually, here it is, what the type of the field it is. But it's not concerned with OCR. It's actually saying, like, here is an invoice ID, for example, or here's I don't know, some other type of identifier, or here is a total amount, but it doesn't tell you what it is. Then there is like line items detection, which will give you the individual cells of a table, for example. Then a classifier, you want to know what the different pages of the document are, whether it's, I don't know, an invoice, purchase order, or something. So that's another model. There are actually more models that are not in the diagram, but last is one that's really important, because as I said, all those three listed, or I think the two listed, I don't know why I made the classifier go to the OCR, that's a mistake. But the two of them, they actually produce bounding boxes and types, and then there is OCR, which reads the content. I don't know if you've heard about any like information extraction system from documents. They are doing it the other way around. They first do the OCR, and then they run some kind of NLP on the result and give you the output. So that's like the big conceptual shift, because yeah, we are doing it basically the other way around. Yeah, and the last part is basically some of the fields may logically go together, like bank details or text details and whatnot. So you need to actually find them and collect them together. So that's why I call it collect. But that's actually an official name. But then normalize, some of the contents of the fields, like amounts or dates. You want to normalize them to some kind of format, like ISO format for dates. And really important part, where I will mention it later, is the confidence model. Because if you want to automate, then you need to have a confidence model, or some model that actually calibrates the outputs of the individual fields. We basically give every single extraction a score that says what's the probability that the field is correct, so that our customers in the end can set up thresholds, even per individual field, how risk averse basically they are, what error level tolerance they want to set. And this way they basically automate when they set either one single threshold, so every single field will need to pass this threshold, every single prediction need to pass this threshold, or they can change the thresholds for different fields, because some of the fields are not important as much as others. I don't know, for invoices, the really important fields may be like date due or something, and total amount, and I don't know, address. It's actually me stepping on this thing. Okay. Yeah, that's basically all these models. I haven't mentioned it yet, but we use Keras or TensorFlow. And the extraction engine, the worker, actually includes all of them or even multiple. But this whole thing is one extraction pipeline, one engine that does extraction for basically either globally, it's like shared engine for all the users of Rossum, and when you use free trial, you will basically use one of those, like we call it generic engine, or other customers have their own copies trained on their data, and that's how we do things. And you can imagine that all of these models we need to retrain for these customers that come, let's say, with their own type of document. Rossum is usually viewed as a invoice extraction company, kind of, but that's not true. We have built the whole technology is completely general, not completely general that we can do anything, but if it's a semi-structured document and you have enough data, then we can train it. So yeah, let's move to the second part. And that's, I don't know if you can read it from far behind, sorry, so I will go through it. That's actually my view, it's my image. I know it's a little bit childish maybe with the colors, but yeah, I'm not a graphic designer. So in the top left, I would call it a center, there is the Rossum app, the core application where the customer or the user of the app or our annotator from our annotation team is actually working and doing the job. They are doing the annotation, and the red triangle actually depicts this data improvement loop, and the main element is the annotation selector, which actually picks from the production the documents which the customers allow us to use for our research, which is really important thing. Some of the customers don't want us to actually keep the data, but whenever they do, they just say so, like, yeah, we need to be compliant with all sorts of things when we, the data are actually sensitive, so they have to give us consent. But when they do, this annotation selector can actually pick them based on some criteria and put them to annotation for our annotation team. So that's one loop, and I will go into the details in all of them. The next one is the green one, which talks about these dedicated engines, which are basically the process of retraining all the models for our customers. And the prominent part in that plays Dojo, which is not really an original name. If you know some other company called Tesla, they have something like that as well. Not really the same thing, but they use the same name. But I think we have been first. I hope so. Definitely not inspired by that. The next loop is about this few-shot learning and what we are actually trying to solve in this loop is the problem of the previous loop with the dedicated engines when we train these models, and it takes a long time, let's say, and we want to provide a... Oh, thank you. Just in time. Yeah, this future learning leap, whenever it takes a long time to retrain the models, and the customers and users are expecting that we will deliver a good job every time they basically upload a document. So they don't want to wait, because one thing about machine learning is that the data may change, and the distributions of your what you are predicting on may be completely different from what you trained on. That's why you retrain periodically. But whenever the retraining takes a long time, you need something to actually compensate for that. And we have another system that actually does that. And maybe the few-shot learning is familiar to you. And the last feedback loop is the big one and the typical one every research should be doing. The important part is we call it accuracy service, which is not like the super original name, but at least it's explainable because that's a service that measures accuracy. And not only that, like automation and all sorts of statistics we can in research use to actually look into like what are basically results, how we perform, what errors we make, and basically focus on target the problems and improve them. So I don't know how I'm doing on time. Maybe I should speed up. So the first loop, the data improvement, that data is gold for machine learning, basically. Yeah, one thing I have already mentioned, we have free trial, and this feedback loop of like improving the data, like we need to build a big enough data set of good enough quality to actually deliver in the first times when we started. And the free trial, we actually are one of few like companies in this information, like what we call it. It's intelligent document processing and something. So we are like only few has this free trial that you can actually try it yourself, what we have built and how we perform, and decide for yourself how it works and what I'm talking about here. Yeah, and yeah, I already mentioned that both data quality and quantity matters, and keeping both is really like keeping both high pays off, especially in the beginning. And if you think about like annotating documents is easy, I don't know, you haven't seen what we have seen. The amount like of the headers and footers and the repeat, like the fields are repeating in the documents. And you basically, when you have a field placed somewhere in the document and you annotate it in the header, and let's say it's repeated in the footer, like what your model will learn when you say one time it's like here and this is correct, and at some other place in the document is the same thing, but you have not said it's the thing. You say actually ignore this. So headers, footers, a lot of problems. Boilerplate, like the term boilerplate is just this template-y thing that repeats on every single page when you upload 10 pages, I don't know, document, and on every single one, the invoice, in cases of invoices, it's invoice ID is repeated on every single document, like page 2, 3, 4, and again, you as an annotator or a user, you annotate it only on the first page. Then again, you have like, I don't know whether to call it like missing data or misannotation. You definitely not expect users to annotate every single page when they see like the field they want. They will annotate it only on a single page, and we have to deal with that. Yeah, it's a cliche, but you need to know your data well and do not sub-optimize unnecessarily, prematurely maybe. And one story I have is really from the beginning of Rossum, when we started like building our OCR model, which is actually open sourced. We have like improved it since then, but you can find it on GitHub. And yeah, we started on like Czech language, and we said like, okay, fine, we will not do any accents and special symbols and so on. So we have spent a lot of time, and I don't know how many thousands, like tens of thousands of documents were annotated without any accent. And then like a customer comes and says like, why can't you like extract the text with accents? Like, what is it? And we said like, fine, that's like logical argument, like let's fix it. And how do you fix that when all your data were annotated without accent? It's hard. But then you ask yourself, why the hell we did not think about that? Okay, things, just bad things happen. And I think I actually know the explanation, because we built our own custom annotation tool, and we plugged in this OCR model. And the OCR model was pre-trained basically with not knowing the accents. And when it's decently good, then the annotators actually see those predicted text and they say like, it's good enough, like, without the accents. And I don't want to spend time fixing that. And that's actually happened with real data. Like the Rossum users will not spend time like fixing all the characters when they are missing like accent. So yeah. Ooh. So, and yeah, I mentioned the custom annotation tool, and once the Rossum app like hit all the necessary features that our annotation team were using in their custom app, we said like, hey, why we have this another system for annotation? Let's use the Rossum app, which is great thing. It's called duck fooding. Basically, we can use them, the annotation team, as our QA, and they can detect errors and notify us, and they can actually track the performance and so on. So I mentioned main disadvantage and advantage, and it's actually not a mistake that the both of the things are the same. You cannot annotate more better than the app allows you. What I mean, yeah, I have rhetorical question, but when you think about it, if your annotation tool is used to train a model, and let's say some customer will adopt it, and you have annotated something extra, and I don't mean annotating something that is necessarily in the output. I mean something that is maybe like a latent feature, we would call it in machine learning, something that the user doesn't want, but it's important to actually extract something else. So when you train a model on that and then give it to the customer and then want to train on it and give it to the customer as a whole so that they will annotate the data, then you have a problem, because they will not annotate the thing that you actually need to extract some of the things they need. I don't know if that was understandable, but it's complicated. And yeah, one big thing I mentioned it is this annotation selector, which is another service that is actually observing the production. And right now it's kind of stupid. It just detects documents that are underperformed, so that the accuracy is at some range or something, and we will just resend it to the annotation team. And the annotation team is a normal, like really, they have their own account, they have their own like workspace in the app, and so we upload it like treating the annotation team as this like company that does the annotations, and they will do their job. So back to the image, I think we will continue with the dedicated engine improvement loop. Right. Yeah, as I mentioned, we are viewed as an invoice extraction engine builders. That's not true. The technology is kind of generic. Anything that is semi-structured or structured, we can basically train the whole extraction engine on. And yeah, very important thing is that we use fine-tuning techniques to actually bootstrap from this generic engine that is used in the free trials and is trained on a huge amount of data. And why we do that, I think Marek mentioned it in his previous talk. You don't want your users to annotate thousands of documents just to train their first engine and start to use it. So this fine-tuning will allow you to actually, it's still pretty good, pretty high. I think we use like 500 documents. And we can go lower, definitely, but at least you will find out what will be the results, and you can iterate on that. But 500 is like the suggested value. Yeah. And what's the next one? Yeah, that's kind of like this. I need to be careful how do I say that, because when you think about it, the users are the annotators from our perspective in research, and what they do when they train their own engine, say they really, the company built bought Rossum, the engine. They want to train their own dedicated engine. And from the users, they will basically train their own companion that will help them do the job, because the engine may have decent accuracy, but not good enough to automate or a decent level. And the more the users are actually validating and fixing the problems, and we are retraining, the more retraining loop we make, then the model will get better, and the people that are actually validating have less of a work, which is a good thing. But what I'm trying to say, I'm trying to avoid the typical, we are replacing the people and robbing them of their job. I personally think this kind of job is completely stupid, and we should not we should have already the technology to replace this kind of job, because you don't study, I don't know, finance, and to then rewrite information from invoices to some system, and you can find many examples. So yeah. And yeah, Dojo, that I don't think, yeah. The Dojo I mentioned is in the middle of this retraining loop, and that's what's basically automating the whole training, and is actually an orchestrator of this retraining. It's doing the management of the whole training, what's the configuration, what needs to be trained, and then actually not doing it to training, it's actually posts this configuration to the Kubeflow, which we use as, I think Marek mentioned Airflow, so Kubeflow is maybe or Kubeflow pipelines is the competitor in this automated workflow in Kubernetes. And you basically, I will try to go through this workflow. So first of all, we use messaging. We use Pulsar in Rossum, but we are transitioning to Rabbit. And when we receive the specification from the backend, from the app, what needs to be trained, just think about it this way. We have this header fields models, this line items models. The specification says what are the types of fields they need to train the model, or what's in the data set, basically. So they specify the configuration in some way, and first the data are collected. Once we have them, then the training pipeline may change based on the content of the data set. So some of the fields may be low in the number of annotations, and there can be some other issues. So you may change what is trained actually based on the data. And so we mix the template for the training, what needs to be trained, the training pipeline, and with the information from the data themselves, and build this actual instance of a training configuration, and that says what needs to be trained. And it's not only about training, it's about validation and evaluation, then putting all things together, building the engine, and actually preparing it for deployment, so that in the end some user can actually click a magic button and the thing will get deployed. Yeah, so I mentioned Kubeflow pipelines that we use for this training, which will basically make sure that all the steps in the training pipeline will get executed in the correct order, so that you preprocess the data set first, then you run the trainings. Then once you have all the models needed to build these extraction engines trained, then you create this extraction engine and you can run the evaluations and so on. And one important part of the whole thing is the end-to-end test. We cannot just, because in parallel with all the trainings, we still work on the things we deploy. I don't know, release daily almost, and anything can happen. So we have these end-to-end tests to really test the engine before it's deployed, that it actually works properly. And yeah, I think I've covered it. And after the whole thing is done, we just post a message that a new engine is ready, and the user in the app can actually set it up. Okay, and second to last is the few-shot learning loop. So I mentioned these dedicated engines, these collections of multiple engines, and collectively they create this extraction pipeline. And the training of all those models can take a lot of time. It depends on the amount of documents we are training it on. But yeah, it can take even weeks. And what if you have customers that are not satisfied with the performance, or something changes during that time, they actually wait for their next training. You don't want to make them unhappy about that. So we developed this completely parallel, independent, or not completely independent extraction pipeline that works basically like a nearest neighbor kind of model, if I may use some technical term, so that whenever a new document is uploaded, we look into the history of that account and find the most similar document. The similarity is vaguely defined. It's not like the same template. It's like really the same like structure. We build embeddings, build similarity metrics, and just pick the most similar. So far we use only one. You can have, I don't know, 3 nearest neighbor, k nearest neighbor, pick the best one and then do some ensembling and whatnot. But we just single one, and once you have this annotated document, the needed piece of information here is that that document was already validated by the user. So we know the right answers on that similar document. And then there we have the models that are actually doing the job of transferring the knowledge from that old document that has been validated and pasting it on that new document. So you can actually figure out what was the baseline for the like the competitor for these more sophisticated models. It was just copy-paste. Because if you find out if it's the same template, like the copy-paste is a really hard baseline to break, because basically if it looks really the same, you just take the bounding boxes and read the text in there, and almost in all cases it's correct. But then you can think about the amounts. Some amounts can be larger, they have larger bounding boxes. So if the historical document have really small amount and then you copy paste the bounding box, it's in the correct location, but it's too short. And then you make an OCR error. That's why we have another model that actually makes sure that whenever that happens, we actually inflate the bounding boxes and cover the text when this happens. Now, as I mentioned, we have this parallel pipeline, and you can improve on the whole system when you put them together. So the old one, the extraction engine that takes a long time to train, you can still use it. It's still being used. But you have this parallel pipeline that's doing this similarity search and like knowledge transfer from the historical documents. Well, then when you have something we call resolver, you have these two independent, not completely independent to be honest, but yeah, fair to say independent extractions. Then the resolver can decide which field from which predictor to use in the output. And then there is really important to have your calibrations, the confidences on your fields on point, because basically that's what you are using to decide which of the models does better job. Because if you use raw output of your typical machine learning model, it will not you are used to maybe use in classification logistic regression, and which kinds of gives you the probabilities, but you may find out they are not really calibrated, which means that the scores will say, I don't know, it's 50%, 51% to be positive, but the number may be not true when you take all the fields, all the prediction of your model that says like 51, and then you actually look at how many of them are correct. If the scores or the predictions are calibrated, it means half of them, roughly, will be correct and half of them will not be correct. That that's what it means to be calibrated. Yeah, so I don't know, I hopefully didn't confuse you, but the main point is you need to have, if you want to do ensembles, you need to have confidence models, calibration, just not to use some raw outputs of your machine learning models and believe like that's the true probability of the prediction being correct, because then you can, yeah, you can still say that, but once the users will start to automate or set up the threshold for automation based on that, then you may find out it's not really working well. Yeah, and quickly the last part, which is the obvious one, is kind of what we do in research. You should know where your bottlenecks are, where you make the biggest mistakes. And I already mentioned the accuracy service that we use to actually measure the performance. And during all those dedicated engine trainings, we know all the results, the evaluations on, we still do the training test splits, you know, so we know how the models perform and you know what doesn't work. So the research part here is to actually focus on where do we make the most mistakes and yeah, try to fix them. It's sometimes hard because like from the product, you know, they will say it's good enough, like, you know, just don't try to fix when from our point of view, it's already working. So, and we are not satisfied with seeing low accuracies. That's the fun part in our collaboration with the product management team. I'm mentioning here the security and data retention constraints. That's one of the things you really need to bear in mind and really implement in all those like data storages, so that, you know, our customers can say based on GDPR or I don't know other rules that or laws that, you know, they want to get rid us to get rid of their documents, and we need to do it basically. And I don't know what you know about research, but research usually is not like the most, like they don't care about this stuff. We just give us the data, we will run the machine learning models, train them, you know, and give you the models, but let's build us for us and let's not care about it. So our machine learning engineers and like the software engineers, our team like spend quite a lot of time like doing also this. And where the exponential like improvement really lies is when you actually these loops where you take them to heart and implement them in your work, and when you build all those single step, when you train your models, how do you prepare your data? If you like build it such that it can be really automated using the MLOps systems, then once you have that closed loop, like, you know, sourcing the data, pre-processing the data, I know selecting the right distribution of your data, your labels and so on, you know, model architectures. Once you have all the training, evaluation, and it's one closed loop, then every single part, it's like a train, and, you know, like usually train has this engine in front, and then like, I don't know what is it called in English actually, so wagons. I don't know, but you want to actually create the engines from every single wagon, and that's what allows it, because then every single improvement in the data preprocessing, I don't know, data selection or like, you know, distribution selection of your data, or even the model architectures, when you put them all together, then you can see the exponential improvement. And you can cover a lot of ground. I wanted to give you an example, but I think I'm taking it too long already. I don't know. So I think I will wrap up. I use this term operation vacation. I don't know if how many of you have heard about it before, but it's coined by Andrej Karpathy. And it's about designing ML systems so that researchers and engineers can actually take vacation, real vacation, for a long time, and the whole system will improve on its own. And that's what I actually trying to accomplish in Rossum, because I think that's something we already are kind of close. We can, you can ask the details when I see where we lack some of the elements, but once you really close all those loops and you have the customers doing the annotations, you automate the training and deployment, everything, then I'm not saying we are done. We will do the last thing. We will just enjoy just looking how it works, like focus on the small things that actually doesn't work. And yeah. I think I will wrap up. I will not go through the summary, but hopefully it was informative to you, and I look forward to your questions. Okay, that's true. And not only that, you don't know how easy it is to actually find all sorts of data on the internet. So we actually created our own scraper, and I don't think it's legal anymore, thanks to European Union. You just cannot like download like invoices and like operate with them without the consent of the people mentioned there or something. I mean, it's hard, I think. And we don't use those documents anymore. So yeah. What OCR engine do you use, or do you have your own? I have mentioned it. We call it, for some reason, Okra. I think it's OCR in Keras, or I don't know what it stands for. It was actually built in early days of Rossum by Milan Troller. Milan Troller. I have to switch into Czech. So yeah, part of his bachelor's thesis, and it was actually one of the first neural network, I guess, or recurrent neural network implementation in Tesseract, which was also an open source, I guess, and we just iterated on that, and it's already knows much more than that published version, but yeah, it's still the recurrent neural network, and it already knows how to read accents and all sorts of weird symbols. Is your company responsible for the errors in extractions? Yeah, good questions. Or do your customers have to review each output? No, we are not. I don't think if we were, it would actually be a good idea. But no, legally we are not. Like, I think that we might have made some mistakes like that led to some issues, but not really big ones that I know of. And we in Czech we say we are z obliga. In layman terms, how do you determine the probability of a given field being read correctly? Confidence level. That's a good question. So, yeah, so you need to split your data set into several parts, then train your whatever the model is, then do the evaluation. From the evaluation, it will basically make the training data set for your confidence model, because when you think about it, that's where you need to split the data set into several parts to actually make it work and to make it unbiased. But once you do that splitting on the validation set, or I don't know if I am saying it correctly, because you have this training, validation, test, there might be multiple splits, but in the end, you have to have like holdout data set really somewhere far, do the evaluation or whatever you use in the end, and then use that as your training for, you do the prediction on the holdout data set and do the evaluation, but train it on that. But the final evaluation is really the one that you use on another data set. I mean, I don't think I did a good job explaining that, but you really need to to make it correct and statistically like unbiased. You really need to care about how you split the data, what you use for training, validation, and for like training of the calibration model, and what are the actual results in the end. Yeah, I mean, good to study statistics and machine learning theory for that and to really know what you're doing. But yeah, maybe, I don't know if I answered the question. Hopefully I did. But do not, one thing I will mention, do not rely on the scores that come out of, let's say, the logistic regression or your, I don't think that any other score will make sense. Logistic regression is usually the probability, but do not rely on that or believe that it actually says the probability of that prediction being correct, because you will find out different models will be biased to different, like, let's say some will be biased towards 0, some will be biased towards 1, and you know how it ends usually. You can definitely do a simple test, what's your calibration of how calibrated the scores are. If you like, you create a histogram, and if you like cover the whole support, the histogram should look like a triangle. So that every single bin, when you like, and the height of that bin says what's the correct how many correct predictions are in that bin. It really should create a triangle. Yeah, I don't know if I'm good at explaining these things without like images or whiteboard to actually draw it. We can go on the next question. How big is your research team? Currently, that's actually a tricky question, because we call ourselves research team, but we are actually something that maybe would be called AI engineering team. And like a true academic kind of research, we have established that like last year. There are already 4 people. In my team, we have 22, 26 in total, so 22. And yeah, I will mention only that we built so many crazy things with so small team. I'm really proud of that team. Yeah, do you treat all of the documents as images? Yes. We had another model, that another parallel pipeline that actually that did that OCR and run NLP, but our models, like the primary input is images. Yes, so it's the first models are basic convolutional, and as I mentioned, we do the OCR at the end. So yeah. Is Rossum next Czech unicorn? I hope so. And we are doing all we can to be so. Do you monitor your models in some way beyond the confidence metric distribution shift? No, not that I'm aware of, actually. No, we use this, like we have accuracies, all sorts of, we break it down onto the individual fields. We have the automation on a document level and field levels and etc. But I don't think we have anything yet. But that's again one small part within some of that feedback loop. When you add it into that, you can again add another part that can improve the whole thing. So yeah. How many invoices you need to train one model? As little as it makes it work. No, it's really, no, that's the honest answer. I mean, as I said, for the custom or dedicated engine, we have this suggested value of 500, but it can be really less. It can be only few, and it just depends how, because we have this pre-trained model and we are fine-tuning. You may find out that it actually works with a few. It also depends on the data. I mean, if the data are, how many well, you need to cover the variants. It's like, it's the same thing with Tesla. I don't know, it works pretty nicely on the nice roads, but whenever you go to India, that, it's, you know, all bets are off, I guess. What is your current extraction accuracy? What are the most challenging fields to extract correctly? It changes, but so far I don't want to say any ridiculously low number, but it's usually between 85 and 95% for header fields. 95 for header, 85 for line items, I guess. We are we are lower on line items. We want to improve on it, and it's still like it's already groomed, and hopefully following quarter we will focus on that. Yep. Are you guys planning to expand the range of products you develop in the future? I don't know what you mean by that. I have only talked about like the research part, but there is a lot of stuff that we are actually building. You would have to be more specific. We have this extensibility workflows that, I will maybe spend some time going back to history, because when we founded Rossum, we built this simple API that did like we predefined set of fields. It was not customizable. That's one of the main like incentives why the customers want to actually train their own models, because we start with some predefined model that can extract only certain set of fields. But whenever you want to extract something new or specific, you just need to retrain, and yeah. And the extensible workflow. So what I mean, why Rossum in that early stage wouldn't work is that basically we would be nice black box in someone else's product. We do machine learning well, and we will make good job extracting the data. But after all, it's what you do with the data. The customers don't want their data in some JSON. They want them somewhere else, or they want them matched with some of their own data in their own data stores. And we build the whole product, or part of the product is concerned with that. And we will find out maybe in the future that there's some machine learning potential in that. And there are definitely some use cases for machine learning, but we are not there yet. Yeah. Yeah, good one. Do you use Productboard at Rossum? Yes. I don't know if Productboard is using Rossum. The company is named after Rossum's universal robot. Rossum Universal, very old sci-fi. Yes, and I don't know who came up with it, to be honest. I don't remember. But our team internally is called Rare. In the first days, it was Rossum's invoice robot. As I said, we are not just invoice extraction engine, so just don't remember that. But yeah, right now we are interpreting it as a research in Rossum. How many people develop, maintain Rossum product? Wow, I think the engineering have like 100 people in total, but it's front-end, back-end, SRE, solution engineering, I guess, a lot of people, but engineering, I don't remember the number, but yeah, it's around that. Do you extract documents as they come or in batch? How long does one extraction take? Wow, yeah, good question. Depends through which pipeline it goes, and we can cut it short. You don't need to go through that few shot learning. We call it instant learning part, but it's like 15 seconds to half a minute to, yeah, it also depends on the number of pages. And what we built so far is meant to really work in batches. So usually the customer, the the users basically upload the documents overnight. They will get extracted. Yeah, I think our goal in the end, it's an ambitious goal to be real time. Like you can have a mobile app, that's kind of a dream at this moment. You can have an app in your mobile phone and just, photograph your whatever the document, and we can extract it immediately. I don't know, like these receipt kind of extraction engines. So that would be cool. But yeah, it's not. We are focusing primarily into automation, and so that the time, this, as I showed that meme or XKCD, so that this gap is really as short as possible, so that the amount of time the user spend annotating or validating the documents in Rossum is as small as possible. How did you come up with the idea of establishing Rossum? What is your background? Yeah, I don't know. The one that asked the question don't maybe know the story, but it's definitely public. We are 3 PhD dropouts. We met at the university, Cseveute, and when we come up with the idea to establish, like Rossum was definitely not the first idea we had, and we actually did something else prior to Rossum, but. Yeah, to be honest, I don't remember. I think it was during the time we were in yeah, I guess it's true. The startup year period, but yeah, no. Hopefully, my co-founder will not bash me for not remembering. But I don't think it's that important. You just need to meet good people, like clever people, and just things will happen. Do they use Rossum? Oh, I think I answered that. Or someone answered that. What is your research MLTA's biggest challenge currently? Biggest challenge? I think it's prediction of what we call absent fields. Because you need to be able to say something is not in the document and you are confident about it. That's really hard. Because you cannot just say that whenever the model doesn't predict something, it means that it's not really there. I hope you understand the distinction. And that's really difficult. Yeah, and I mentioned the line items. That's one thing that we would really want to improve. Is Rossum hiring? I think we are definitely hiring, and yeah, we have the career pages, and I hope some of our recruiters are here, so what is the size, number of employees, average revenue of your average customer? Good question. I'm one of those founders that are really technical and don't care about these things that much. So I honestly cannot answer that. And I actually don't even think I should be answering that. But, again, I'm really focused on the research and the things we are doing in research. Are there any special non-conventional data augmentations that you apply in any of the models? We do all sorts of crazy stuff and non-conventional. I think Bohoj, the team lead of OCR team, is pretty proud of some crazy distortion, kind of that the document looks like it was squashed or and then flattened, and these, I don't think it's that crazy, but we do all sorts of stuff. How long does it take to train the largest model? Oh, I think like 3 to 4 weeks, something like that. Again, I don't know the exact number, but as far as I remember, that's more or less correct. Is there a field in, let's say, invoices that you struggle with force confidence more than with others, and why do you think is that? Question. I'm not really it's not long since I like stopped being hands-on, and but I think it's definitely the line items, and I know I didn't go into the details, but when I say line items, I don't mean only like this pretty nice grid. You can have like with grid, you can extract only like normalized data in database sense, that all the columns really contain the single value like amount. But you can have documents that contain within the single column different data types. Then you have a problem that you need to have another extra model that will actually do the job and differentiate these things. And yeah, I think that's the hardest part in those special non-uniform, not nice line items. But from header fields, let me think for a second. No, I don't think I recall anything special like that is worth mentioning. Can Rossum engine be used for automated web scraping? Not yet. Maybe some hackathon, and but yep, that's I guess it. It's another type of structured documents. The web pages of, let's say, e-shops. I think we could train the engines on like extracting like e-shop sites and like figuring out what's the name of the product, what's the price, even what's the image, and so on. So not that we would read anything from that image, like being able to actually extract. That's maybe one of the header fields we are struggling with, or we don't have solution yet. And that's when you are missing the name of the company and it's only a logo. And the users will annotate the logo, and the logo usually has, as a human you will understand from how the logo look like. I'm not talking about just big font kind of logo, readable, but some graphical kind of design kind of logo. We are not able definitely to extract text from that, but yeah, again, in the future, if the case is big enough, and we can do that. And that's the last question, so thank you a lot.